Okay, guys, lesson 3.3 are 2D projectiles, meaning it's going both horizontally and vertically. That's the two dimensions. We're going to look at two examples here to show you how it works. So the first example just is a cannon firing a cannonball horizontally off of a cliff. We're going to look at the velocity of what's going on here each second. Okay, we'll break it down into like 3 seconds here. So at 0 seconds, so we've got this initial situation, we've got this v x0, okay, we'll say that's 20 meters per second. That's the initial x velocity. Your y velocity is 0 here, because it's not moving vertically. Okay, at 1 second, what's going to happen? So this is 0 seconds, this is at 1 second. This will stay the same. So your Vx, we'll say now let's call it Vx, is still going to be 20. That's the x velocity. Your y velocity at this point, our Vy, is now going to be negative 9.8. Okay, it's kind of small here. I don't know if I can actually zoom. Okay, so your y velocity, I'll zoom it in here, is just the negative 9.8. The x velocity is at 20. Okay, go another second, it's going to fall somewhere down here. Your Vx actually stays the same, still 20. Your Vy is the one that's going to increase, be quite a bit longer here. Our Vy now is going to add another 9.8 onto that, negative 19.6. Okay, and then every second that's just going to get 9.8. Negative 9.8 added onto this, okay, and so on, and it will do that for however many seconds it's in the air. Okay, the interesting thing is if somebody had dropped this cannonball, this is kind of a cool connection, and just let it fall, say straight down, at the same time that this one was shot out, they actually would hit the ground at the same time because their y velocities are the same. So it's kind of like this is changing, the y velocity changing, the x is just staying at 20. It's just moving. If you were to run directly underneath this as it was shot, you could just run at a constant speed of 20 meters per second, and then boom, it hits you on the head right here. Okay, the x velocity is just constant. You can imagine that. Okay, let's do an example when it's launched at an angle. Okay, so down here at the bottom, I'm going to start it. Say the same thing, a projectile launched at an angle. It'll tell you the angle from horizontal, and it will give you a velocity to start. So let's say the initial velocity they tell you is 30, and let's say the angle from horizontal is 70 degrees, so pretty steep. So what we're going to want to do is find the two components. Okay, go back to last week, the components. You got an x component and a y component. I'm going to do this parallelogram method. You could do tip to tail, put the arrow here and here, it'd be fine too. I just kind of like the looks of this better. Okay, here's Vx0, the initial x velocity, and we're also going to have a Vy0. Alright, it's going to be moving both horizontally and vertically to start. You would use sine, cosine, tan. Alright, to save you, since I feel like you guys are good on that, I feel like I can just kind of bop through that. It's going to wind up, for this one, the x is always going to be the cosine, right? Adjacent over hypotenuse. So it's going to be 30 times the cosine of 70. That would be 10.3. We'll just round to the nearest tenth. Okay. And then the y velocity, or the y component here, which would be like this side here, is going to be a sine, right? The opposite over hypotenuse would be y over 30. So the shortcut on that is just say, okay, it's going to wind up being 30 times the sine. 28.2. Alright, those are the initial conditions when it's shot. It's going sideways at 10.3 and it's going up at 28.2. That's why I put the 0 there, because that's like the initial. Now it's going to kind of fly through the air and eventually come to a top. Let's do like 3 seconds or a couple seconds here of what's going to happen. Okay, interestingly, this stays the same. So after 1 second, my Vx, I'm going to call it, is still 10.3. Okay, my Vy is going to decrease, right? It's getting slower in the y direction. I'm actually just going to minus 9.8 from that, so 28.2 minus 9.8. We're down to 18.4 for my Vy, meters per second. Okay, and you could figure out what's going on with this, but for the assignment, it's just going to ask you to find these components because that's really what's kind of important here. Okay, let's go another second. Maybe it's gotten to like here. Vx still 10.3. Vy, now I'm going to be down to minus 9.8 from that again, 8.6. That's my Vy. Okay, meters per second. Boom. Parallelogram. Boom. Okay, and then let's go one more second because you'll kind of guess what might happen now. It's going to be at negative 1.2 on my Y, meaning it started to go down now. Okay, small arrow going down. This is still the same. Vx, 10.3. Vy, put it here, is, what was it, negative 1.2. Okay, so now it's actually going down like that at this point, right? So you can kind of see the path is going to follow this parabola, okay, like that. Okay, if it said find the time when it gets at its max height, you could estimate, its max height is going to be between, what was this, 1 second, 2 seconds, 3 seconds. So the max height, or max height happens at about, it's probably 2.8 seconds. I mean, that would be a guess. If you wanted to figure out exactly, all you'd have to do is say, well, 28.2 is your Vy, and then it's got to get down to 0. So really, let's write the equations here. So you got those. Vx is constant. Here's the equation for Vy. The Vy at any time, you just take your Vyo minus plus actually AT. Okay, that's hopefully looks familiar. It's like we did V equals Vo plus AT. That was chapter 1. This is similar. It's just looking only at the y direction. So to find the y velocity in the y direction, you take your initial one plus AT. So for example, say we wanted to do at 4 seconds. We'd say Vy, well, I take my Vyo, 28.2, plus the acceleration is negative 9.8 times, what, 4 seconds? Okay, and obviously that just means minus 9.8 4 times. It's going to be at negative 11. Okay, so that's kind of just a connection to the equation there, but really the main goal for today is draw these pictures out and just look at the pictures to get your answer. But just so you know, if you did want to find the exact time to get to the top, you would just say, well, when's my Vy at 0? I'd put 0 here, I put 28.2 here, negative 9.8 there, and then solve for t. Okay, and that would give you the answer, the exact answer to this. Okay, that should get you through your assignment today, guys. Good luck on that.